Hi, everyone. Here we introduce our latest research, few-shot font generation by learning fine-grained local styles. Due to the high expense of generating a new font library, automatic few-shot font generation based on deep learning has drawn rising attention in recent years. The goal is to generate a brand new font library with only a few characters as references. The intuition of our work comes from real practice. When experts design a font library, they would carefully design every possible detail. The detailed styles among components, strokes, and even edges are designed to be consistent. An ideal font generation model should be able to generate consistent characters. Therefore, the main motivation of our model is to learn the fine-grained local styles and aggregate the corresponding local styles from the references. In this way, the fine-grained local styles of references are largely preserved. The contribution of our work can be divided into three parts: a style aggregation module, a self-reconstruction branch, and a reference selection module. Given the content image and the K-shot reference images, the content encoder and the reference encoder extract the corresponding fine-grained feature maps. The style aggregation module enables our framework to learn the spatial correspondence between the reference map and the content map. The core in the style aggregation module is a multi-head cross-attention block. It attends to spatially local styles from the reference maps and aggregates the reference styles into the fine-grained style representation for the given content image. In our practice, we found the model can hardly directly learn the correspondence between weakly correlated content and references. Therefore, we introduce a self-reconstruction branch in our framework. In this branch, the reference image is set to be the target image. This is an easy task to help the model learning. To select proper reference glyphs, we firstly decompose each character into a component tree based on a commonly used decomposition table. We define the components at the level 0, 1, and 2 as the conspicuous components, which contains both radical and compositional structures that easier be transferred from the references to the target. We compare our results with previous methods. We test the models under two setups: unseen fonts seen characters and unseen fonts unseen characters. Our results outperform other competitors in both qualitative and quantitative aspects. Especially, the qualitative shows the proposed fsfont can generate images with fine-grained style preserved. For the ablation study, we first examined self-reconstruction branch. Qualitative results show that it significantly boosts performance. Models without self-reconstruction branch can hardly recover details from reference images. We also conducted an ablation study to examine the impact of the three key modules individually. By discarding the style aggregation module, self-reconstruction, and reference selection individually, we can see that all these modules have positive effects on the original model respectively. The model with three modules has the best performance in all evaluation metrics. To demonstrate the effectiveness of the style aggregation module, we visualize the attention maps for different levels. The visualization results clearly show our framework can learn the correspondence between the style and the content. We show more visualization results of the style aggregation module. This figure covers characters with some typical structures. Moreover, the proposed fsfont is also capable of process Japanese kanji, Japanese kana, and Korean. Here are some demo cases.